Hi, welcome to our next level 2 probability video. In this video, this will be our second video. We're going to solve normal distribution problems with the graphics calculator. So let's get straight into example 1. Hopefully you've watched the first couple of videos and feeling okay about normal distribution. Here we go. Number 1. The birth weights of baby girls at Wellington Hospital have been recorded and appear to be normally distributed, with a mean mass of 2.6 kilograms and a standard deviation of 0.3 kilograms. So we'll start off by drawing our normal distribution curve and putting the mean of 2.6 right in the middle. Right, well here's part A. What proportion of baby girls at Wellington Hospital will have a mass less than 3 kilograms? Well, proportion means probability. So what we're going to do, once again, we're going to highlight the number 3 and we're going to colour in everything less than 3, which represents all baby girls that have a mass less than 3 kilograms. Right, let's go through the process on the graphics calculator once more. We go into statistics, we go into distributions, which is F5, normal distribution, F1, and normal cumulative distribution, which is F2. That'll bring us to this screen. And now we're going to type in the lower, upper, sigma, and mu statistics. So the lower boundary is, well, this is where we're going to get arguments. You're going to say we can't have a negative weight. And I agree with you. So 0 probably is the right value to put in here. But I want to put in a value that is so far to the left that it represents all baby girls being born. Now in this example, 0 probably was okay, but in some examples, even 0 is not small enough. The upper boundary is 3 because we want all baby girls less than 3 kilograms. Sigma, which is the standard deviation, is 0.3, and mu, which is the mean, is 2.6. Now when we execute and solve this, we get a probability which we're going to round to 4 significant figures to 0.9088. So the proportion or probability is 0.9088. All right, example 1, part B. What percentage of baby girls at Wellington Hospital will have a mass between 2 and 3 kilograms? This time we're finding a percentage. Same thing as a proportion or probability, we're just going to multiply it by 100 at the end. So our normal distribution curve will look the same with 2.6 in the middle. And we want to know what percentage of babies are between 2 and 3 kilograms. So once again on our diagram, we're going to colour in 2 and 3 roughly as an estimate. And we're going to colour in all the area between. So going back into our calculator, here are the statistics we need to put in. The lower boundary is 2. The upper boundary is 3. Sigma still is 0.3 and the mu, the mean, is 2.6. And when we solve this problem, we get a probability of 0.88603864. We're going to round that to 4 significant figures once again. It's a common thing we do in probability, but this time because they want a percentage, we're going to multiply that number by 100 and write it down as 88.6%. 88.6% of all baby girls born at Wellington should be between 2 and 3 kilograms. All right, part C. What's the absolute risk a baby girl at Wellington Hospital will have a mass greater than 3.3 kilograms? Well, here's our distribution curve once more. This time, absolute risk. Well, it's a term used in the medical profession, but it still means probability or proportion. So the same thing applies. So on our diagram, we're going to colour in 3.3 and everything up greater than 3.3. Here is our statistics. Our lower boundary is 3.3. Our upper boundary is going to be a value miles off. I know you're going to argue 10,000 kilograms is ridiculous, but I just want to make sure it covers all babies that are greater, way out on the right-hand side. And our probability comes out to be this value here. Now, what the heck is that value? It's this decimal, and I'll show you how to get that decimal. We start off with 9.815, and we move the decimal point once, twice, 3 places. That's what the negative 3 means to get 0.009815. Thanks for watching.